Hey, D. Dykstra here. How you doing? Ready for another math-tastic video. All right, check it out. Limits to infinity, sine and cosine functions. So let's check it out, see what's happening. All right, we have sine and cosine functions. So what we want to think about first of all is some basics that will really help us. Is what is the range that sine and cosine work within, right? So sine and cosine, they both work within -1 to 1. So anytime we're dealing with those values, we know it's not going to go outside of -1, and it's not going to go any outside of +1. Because if you've ever tried to take the cosine of some angle that equals 2, it doesn't exist, okay? So when you're dealing with normal unit circle. Now when you do a sine curve and you have an amplitude change, of course some of those things can change in that respect. But in and of itself, cosine and sine never change outside of -1 and 1. So what we want to do is some strategies. How do we do this? Well, think of the limiting values of sine x and cosine x. What are their limiting values? Okay. Then, what other x may be in the numerator or, and we should put, or in the denominator. So I'm going to write that out for us here. Or in the denominator. Right? Because if there's an x in the denominator, what's going to happen with that x eventually? What will it do? Where will it grow? And if it's growing and the x is in the denominator, then typically it might grow without bound, and thus we're left with a 0 as a limit result. Okay, so those are some strategies and trends we want to look for. Example number 1. Here we have 1 over 2x plus sine x. Exactly what I was talking about in the denominator. Here we have an x in the denominator and we have a sine x in the denominator. Now recall, sine x goes from -1 to +1. So we know this value right here, this sine x, is going to vacillate between 1 and -1. That's all it's going to do. Okay? So whenever we multiply or we add something that's growing, 2x, changing, even if we change this angle quite a bit, it's only going to be between 1 and -1. So we'll either get a -1 or a +1. If I add that to something, then I would get a fixed value. However, if that value of x is going to infinity, we have to notice that 2x in the denominator, as x goes to infinity, what is happening to the value of that numerator? Well, that numerator is growing. The denominator is growing without bounds. So the numerator is shrinking, 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 until it becomes arbitrarily close to 0. And we could basically just look at the function like this and say, well, what happens with 1 over 2x? Well, if x continues to grow, this value is going to go to 0. And that's right. Okay? So this one, because this 2x right here takes over as this 2x grows, right, that is the determining factor, not so much the sine x. All right. On to the next one. Example number 2. Here we have limit as x goes to infinity of sine of 6x over 2x. Again, we have a 2x in the denominator, and we notice that sine of 6x, this rotation, this multiple of a rotation, is still going to be bound by the -1 and 1. So we've got a -1 and 1 situation in the numerator, and then the denominator is basically a sine 6x over an x value, right? And when that x is growing, it's like taking the limit as 1, -1, right? Because that's the sine. It can either be -1 over an x or a +1 over an x. Really, that's what we're saying. This sine of 6x is going to change into a +1 or a -1 by the range rule. So, if we think about what is happening with just an x in the denominator, then if we know that the limit of -1 over x goes to 0, and the limit of as as x goes to positive infinity of 1 over x, that also goes to 0. Well, and that leaves us this function as the limit of x goes to 0 of this function. Then, well, what's between 0 and 0? Well, can't be 1, can't be 2, can't be 5, I don't know, right? It's got to be 0. So, hence, the limit as x goes to infinity of sine of 6x over 2x, right? Add our 2 back in, and it is still 0. All right? Good. Next one. Final one. I know, look at that graph on me. It's cool looking. All right, check it out. This time, and I'll hide the graph for a minute. Don't look at the graph. The limit as x goes to negative infinity. Now we have an x in the numerator, and we have a cosine 3x in the denominator. Again, cosine 3x doesn't matter what this is doing. This changes the period, if you recall. Okay, this changes the period, and it makes it also it makes it go faster. Right, there are 3 times as many rotations in 0 to 2 pi as there is in a normal cosine of x. Still, negative 1 to 1, right? Negative 1 to 1. We have to ask ourselves, when is cosine of x equal to 0? Question mark. And pause the video and see if you can answer that question. Go to your unit circle. Check it out. When is cosine naturally occurring at 0? All right? I'll wait. And back. All right. Yes, you were right. If you look at the unit circle, cosine is naturally 0 at pi over 2 and 3 pi over 2. Why do we ask that? Well, look who's in the denominator. If we get something that ends up with a 0, that becomes a no. A number over a 0, which is undefined. Remember, a 0 over a number, that's just 0. So recall, a 0 over a number, that is okay. I can't believe the lights just went out. Well, we're almost done, so I'm going to let it go. Limit as x goes to negative infinity of x over 3 cosine x does not exist. I'm going to do this. Let's jump out of the screen for a second. Can't believe that happened. All right, and we're back. Okay, it's all right. It's just a public video. No big deal. No, it's undefined, or 0 over n. Hence, the limit as x goes to negative infinity of x over 3x does not exist because of the oscillating features of the graph. Because every pi over 3, or if we plug pi over 2 and 3 pi over 2 in here, then we get every 3 pi over 2 or 9 pi over 2 or so, then we would get an asymptote. And that's what we would see is in between here we have these running asymptotes that come down and tell us that, hey, you can't go past the asymptote and so forth. And so that's what we get is it breaks it up. Hence, if you can't jump over the asymptote, well, then you can't keep going to infinity. So therefore, there is no limit, and it does not exist. All right. Well, I hope you enjoyed that. It's me, T. Dykstra, back with you again as the lights go out. And that is limits at infinity of sine and cosine functions. All right. Thanks. Have a great night.